Welcome to Making Waves.
Welcome to Making Waves.
Fresh ideas in freshwater science.
Fresh ideas in freshwater science and why they matter to you.
Making Waves.
Making Waves is brought to you.
Making Waves is brought to you with support from the Society for Freshwater Science.
Welcome to Making Waves. I'm your co-host, Erin Larson, and you're listening to part 3 of a 4-episode mini-series on education in freshwater science. In each episode, freshwater scientists will talk about an activity they've used in their class, ranging from activities that take just a few minutes to entire modules of a course. We hope these will help everyone, from high school teachers through college instructors, get new ideas to use in their classes. In this episode, I'll be talking with Kaylin Carey, an assistant professor at Virginia Tech, and Kate Farrell, a postdoc at Virginia Tech, about modules they've developed to teach students to work with large freshwater datasets and modeling. Welcome to Making Waves, Kaylin and Kate, and thank you for joining us today. So to start with, I wanted to talk about what inspired you to create the activity that you'll be describing.
Sure. So I feel like it's really important to start with Project EDDI, which was actually motivated by climate change. So EDDI stands for Environmental Data-Driven Inquiry and Exploration. And this was the collaboration that started in 2009 between myself and Dave Richardson and Catherine O'Reilly. And we were a bunch of early career scientists. I was actually a grad student at Cornell, and Dave was a first semester professor at SUNY New Paltz. And we had to all of a sudden create these labs for freshwater ecology courses. And it was winter, and it wasn't actually safe to go out and sample lakes and streams to the ice because it was a really warm winter. And so we decided that we wanted to pull together some really cool data sets that we've been working on for research and to use them as a basis for teaching freshwater science. And so this was also kind of came out of our work in GLEON, the Global Lake Ecological Observatory Network, which was the context in which all of us knew each other. And so we started developing teaching modules that we were creating for our own classes, but knowing that they were going to be taught in each other's classes too. And in 2012, we received NSF funding to support scaling up Project EDDI to include 10 different modules. And we also brought in researchers that specifically focus on pedagogy. And the idea behind our modules is that they're flexible and adaptable and have a scale of scaffolding activities. We usually refer to these as A, B, and C, so that maybe for your intro-level classes, we'll teach A and B as homework. If you have a more senior class, maybe there's pre-readings that you would do A and B, and then you do C in class. And there's usually homework questions, data sets, and kind of a range of different activities that are geared around different ecological concepts. But we're really excited about using real messy ecological data sets to teach students about different concepts. And the idea is also that we're using these data to help teach them quantitative skills. So data analysis, data visualization, looking at variability in real ecosystems. So that project was funded from 2012, 2013 to 2017. And then I received funding as part of a macrosystems grant to kind of have the next generation of Project EDDI, which is called Macrosystems EDDI, in which we are using the same concept of using teaching modules to teach macrosystems ecology concepts. And Kate and I coordinate Macrosystems EDDI together. And we're still teaching Project EDDI modules, and Macrosystem EDDI kind of builds off of Project EDDI in that we're using primarily R-based activities instead of Excel. And we're thinking a lot about how do we use ecosystem models to teach students about cross-scale interactions and feedbacks that are occurring at a larger scale than perhaps in just one or two lakes.
Awesome. And so it sounds like you have done this activity across a bunch of different types of classes and institutions, but what's sort of the general class context where folks have used Project EDDI and Macrosystems EDDI?
So I can speak for Macrosystems EDDI. Most of our testers so far have been environmental science classes and ecology classes, ranging from introductory classes to more specialized sort of freshwater ecology or limnology classes. We design all of these activities with the goal that they can be used by students and instructors who have never used R before. And I think that's a really important part of it, to try to break that mental block about trying something new. So we designed each of these activities to be about a 3 to 4 hour total time commitment, with the idea being that they could either be taught in one large lab period for classes that have a lab, or if it's being taught in a lecture class, they could break it up into multiple days, sort of along those A, B, C activity breaks, or sort of select the subsets that best work for their lecture. Because we do have a lot of both students and instructors who have never taught in R before, we've developed some also scaffolding materials to help try to bring the students on board and sort of orienting them to our studio and making it as unintimidating as possible for them to get started with it. And in terms of thinking about the instructors trying them out for the first time, we often recommend that the instructors give the module a full test run on their own before they try it in the classroom, because every computer is a little bit different, and as much as we try to put the modules through lots of different testing scenarios with students and graduate students and ourselves, there are always sort of nuanced computer challenges that they might run into, and it's best if the instructor has a little bit of anticipation of where the bumps along the way might be for their particular students.
To date, we have taught the Project Eddie modules to somewhere between 10 and 15,000 students. And for the Macrosystems Eddie modules, we're hopefully going to hit 500 very soon. A really important part of our program is that we very thoroughly assess the modules, in which students complete pre and post module questions that we are using to constantly revise the modules and update them. And so, for example, one of the kind of changes that we've been working on is in one of our new Macrosystem Eddie modules, students develop their own climate and land use scenarios and force a lake ecosystem model to see how the lake responds to potentially different alternate futures, and trying to predict where the likelihood of degraded water quality is greatest in different lakes. And what we found was that for some classes, it just takes too much time to complete in a 3-hour lab period. So we just have now pre-made scenarios based off of downscaled RCP predictions for different lakes. And so we've been trying always to make it as adaptable as possible for different classrooms, so that if you only have a 2-hour lab, you could still run our modules. If you have a 3 to 5 hour lab, you could have the students create their own scenarios.
Awesome. And so it sounds like from your description, most of this is like, if you were to sort of briefly describe what the different modules are like, that's sort of a really interesting example of one of them. So they're all working with some sort of big data set in limnology, right? Or some sort of environmental data set, and then using R to analyze that in some way.
Yeah, so the Project Eddie, the original suite of modules, had a number of different topics where many of them were water focused, but there were also some soil and earthquake type modules happening. The macro systems one, because Kaylin is leading that project, we've decided that we're making them all limno focused. And our classrooms have been often aquatic focused, but not always. But we find that because of the GLEON data sets, NEON data coming online, USGS gauge data, there's just so much available high frequency, messy, real ecology data from aquatic ecosystems that we found to be a really nice, sort of also a closed system where we can have students run a whole ecosystem model. For each of the Macrosystems Eddie modules so far, we're using the General Lake model, which is an open source whole ecosystem simulation model that we set up and then have the students test different scenarios in. And we've just found so far that the lakes seem to be really a nice system for trying out these sort of ecological data manipulations and scenario building.
That's cool. And it's obviously, lakes are a nice sort of contained ecosystem in a lot of ways for thinking for students for the first time in some cases about ecosystem modeling and things like that.
Yes, it definitely helps to be able to put a little bit of a bound. And we don't provide them with all the caveats about the terrestrial lake interactions, but so for the purposes of the modules, they see them sort of as a unit, which is nice.
Yeah. And you guys have described a little bit how instructors can prepare to teach these modules, and it sounds like you recommend that people sort of take the time to go through as if they were the student first. Is that what you would say is the preparation time, more or less?
Giving it a try yourself in R, especially if you're new with R, is going to make teaching it in front of the students go much more smoothly. As part of the packet of materials that we develop, though, we do create an instructor's manual that has some background information. We have an introductory PowerPoint that the instructors can either use as is or modify it to their classroom that has speaker notes and sort of little nuggets of things that they might want to highlight for their students. There's another optional PowerPoint that walks through the introduction to R so that they could sort of orient students in R if they need to. And we also provide a student handout worksheet where it has some guiding questions that the students work through as they're completing the module, which helps a lot for helping them slow down, make sure that they're reading materials and not just getting so wrapped up in the excitement of R that they skip sort of the ecology lessons that are embedded within the module.
I think another part of this is that we really encourage students to work together in teams to complete the modules. And we found that when you have two students working together, that one tends to be in the more dominant position because they're working on their computer. They can kind of run the code much more quickly, and you have the partner who's kind of left to the side. But if you have kind of stopped or you have the handout and other ways to kind of stop with embedded discussion questions, that helps keep them both engaged and still allows them to work together to kind of leverage each other's expertise for trying to understand how best to work through the code or the problem set.
And so in general, folks are working in teams or in pairs when they're working through this?
In some of the modules, we have kind of a menu of lakes where students can pick, and we encourage pairs to be working together, kind of quartets. And so they'll be working through different climate scenarios and different lakes and then seeing how different lakes are responding. So, for example, in the teleconnections module, which is a new module that Kate just developed, which is looking at how El Nino is affecting lake dynamics and water temperature and water level across the U.S., you can have the same climate scenarios and the same El Nino years affecting lakes that have different characteristics in really different ways. Mm-hmm. And so we're looking at where a lake's geographic location will alter how its response to El Nino is during a very extreme El Nino event, for example. And so that's been really fun, too, to have students kind of think about the context of where their lake is located and to be able to compare. And so that helps with I think, kind of the discussion as well of why some lakes are responding in different ways than others.
Awesome. And so it sounds like you guys have done a lot of thinking about how this activity can be adapted to different types of classes. But have you seen any challenges with having it for a more introductory class versus a more sort of specialized or majors level, more senior class? Do you think it could be taught at a high school level?
Yeah, I think it's certainly possible to teach it at a high school level. You would probably want to break it into maybe more of a subunit where you're spending a little bit more time building some of the ecological context in, for example, like a high school environmental science class. But also digging in a little bit more on R and the structure of R and why we would want to use things like simulation models. So maybe it's that the 3-hour module gets blown into a week-long unit or subunit on ecosystem modeling and is adapted that way. And I think the using of the script itself is certainly transferable to high school students. I know one challenge that we had this past academic year is we had a freshman level class at one of our tester universities was using the module for the first time, and the students got so bogged down in trying to do some of the installation steps. They were having a lot of computer problems. And so that's part of what Kaylin mentioned, where we're constantly doing the updates, is hearing back from our testing faculty, seeing what bumps they've hit, and if we're able to streamline any of those at all. So I think a lot of times the senior level or junior level students have just had more experience with sort of hands-on labs and maybe with different computing activities. So for introductory level classes, just splitting it out so that you're not rushed and the students have the time that they need to work through those tricky spots, I think has been our main findings so far.
And also things like using computer labs on campus or other resources where we've packaged the modules in different ways to try to make them as most accessible as possible for different levels of students. With the idea being that the ecological concept should come through whatever combination of activities you use, but you might want to use different activities for undergrads versus grads. So, for example, I teach an undergraduate freshwater ecology class, And I teach EDDI modules in both the lecture and the lab, but I've packaged some of the modules that are going in 2 1-hour lab or lecture periods in a different way than I do for my 3.5 lab periods. And so I feel like there's kind of something where I think a lot of this is knowing what's best for your students and knowing where their level is. And that's something which can be hard for first year professors or first time you're teaching a class. And so Kay and I are really committed to helping our instructors that are testing out our modules so that we can help you essentially do whatever you need to do in terms of editing the modules or cutting them so that we can do what's best for your students.
Yeah, it's sort of like following a recipe where you have to make your own tweaks along the way. That's how I always think about teaching in a lot of ways when you get resources from other folks. And so it sounds like you both have done a lot of thinking about sort of updating the different modules. We've sort of covered some of the ideas of like things that you've done in the past and how you've changed it moving forward. What are you sort of thinking, I don't know, in the next few years or bit of time you're sort of planning to do with Macro Systems EDDI?
Well, we still have 2 brand new modules that are on the docket for being built. So that will be sort of our first big next step is that we have a module. So far, our modules that are available are about lake climate change effects on lake temperatures, cross-scale interactions, and a teleconnections module. And our other macro systems topics are for macro scale feedbacks and then sort of a synthesis module. So we'll be building those out in the spring semester and then testing them. And then after that, next steps with macro systems EDDI, I think it's a really exciting time with the neon aquatic data really starting to come online. The infrastructure is in place now, but the data isn't quite available in the time frames like a full year's data to plug into these modules. So I'm excited about making some updates.
One other thing I'm really excited about is that some of our colleagues in Gleon have started teaching our modules in their universities, not in the US. And so thinking a little bit about how we can best adapt these modules so that they're global in scale and not just focused on the US. And so thinking about building in more lakes to model, capturing more gradients so that students can really understand the full diversity of freshwater ecosystems. And then Kay and I have been talking a lot about different ways of thinking about the next generation of these modules using R Markdown and Jupyter notebooks and kind of moving into potentially other languages too, in addition to R, for thinking about what data analysis skills and what data science skills can we embed in these which can help train the next generation of ecologists.
That's awesome. And so do students generally like these activities? Are they reacting? I mean, I'm sure they are loving them. I didn't mean to sound skeptical, but what's some of the student feedback you've gotten in terms of things they really enjoy when they do these modules and things that they're either struggling with or maybe they don't like as much?
Yeah, so I think it's funny that you mentioned being skeptical because I think a lot of times, at least for the times that I've helped teach the modules here at Tech, the students are really skeptical. You're asking them to download a new computer program, R and R Studio, that they've never heard of before, or they've heard of, but in sort of this really worrisome way, like, oh, R. Then they open up the program and there's nothing there, right? So they're like, you've got to be kidding me. We have a lot of skepticism from the students about being able to run the program, being able to figure things out. But I think once they get through that first step of getting their computer set up and they run the baseline model for their lakes, they get so excited because they're like, look at this heat map, it's so beautiful. And then they run their climate scenario or their land use scenario, and they start thinking right away about like, well, how realistic is this? Or what if I change that instead? And so I think that they get really interested in the power of using R and the power of using these whole ecosystem models because it just opens up ideas for them that they never would have been able to access using like Excel or the other tools that they've been familiar with so far.
One of the things that I've really enjoyed is seeing students realize the power of modeling for thinking about future change. And so generally I group the students into 2 categories. The first is when they have to develop their own climate scenarios for a lake. They will try to get as specific as possible for a lake that's special to them, maybe a lake where they grew up or spent the summer on as a kid. And they'll really try to look and see, how is this lake going to respond in the future? The other group are the students that are all for just trying to use the sledgehammer. So what happens if I increase precipitation by a meter a year? Or what happens if air temperatures go up by 15 degrees C? And so I feel like that's also really valuable too, for being able to isolate those particular drivers in a way that you just can't in real life. I think the other thing that's emerged from both Project Eddie and Macrosystems Eddie is when students are working with real data, they're always struck by how messy it is and how variable it is. In terms of thinking about, if they're looking at historical data, maybe they have an annual mean, but actually looking at minute resolution data from a buoy, I think blows their mind in terms of, oh my goodness, I had no idea that thermocline moved up and down, or that water temperatures varied that much. And the third is, which I think I'm probably the most proud of, is that the data from our assessments continuously show from both Project Eddie and Macrosystems Eddie that what we are doing is helping to build students' confidence in using these tools. And that's the first step in terms of making them proficient, in that they feel more confident programming, they feel more confident working with big data in a way that I don't think that they're getting exposed to in other classroom activities. And so I think Kate and I both feel really proud in that we're trying to empower students to get excited and to feel like they're able to do these activities in a way that just simply wouldn't be possible otherwise.
Yeah, that's awesome. And it sounds like it's teaching them some really important science process skills too, in terms of thinking about the fact that science is not a lot of very clear cookie cutter answers to questions, which in some cases might be the first time they're sort of experiencing that. And so it sounds like both of you have had a lot of great teaching experience in the aquatic sciences. And so I was wondering, for my last question, if you could share any advice that you have for folks who might be teaching in the aquatic sciences for the first time, whether they're a grad student or teaching for the first time, a new professor, anything like that. And I know it's a continuous learning process, but if there's things that you've learned or reflections you have on teaching that you'd like to share.
For me, I think there's something that's really important about being fearless, and that it's inevitable that you're going to be doing some kind of activity and that it's going to completely bomb, and being okay with that. And I remember the first time I taught one of our primary Macrosystems Eddie modules, which is all about introducing students to climate change effects on lake temperatures. And the first time I taught that, students just looked at me and they were so overwhelmed, and I was so overwhelmed, and I was a first semester freshwater ecology professor. And there's something about, I honestly feel that if you are excited and enthusiastic about what you're doing, your students will be too, even if maybe it needs to be refined, or the next iteration of that lecture, will be more interactive. But there's something about, you just need to put yourself out there. And I think whenever I'm excited and enthusiastic about any of these modules, students are there with me. They want to be excited. And so I feel like that's 95% of my teaching, is me doing a Daphnia dance or getting really excited about thermocline and seiches. Today was seiches. It's my lecture, so I was really excited about that. And you can do anything if you're excited.
Yeah, I found, at least with teaching these modules, that it's really important to also show the students that it's okay to be vulnerable in how much you know and how comfortable you are with the data sets. So I think that they have gained a lot when there have been times when, I screw up something in the demonstration, or, we run into an error message that we haven't seen before, and they see me sort of panicking, trying to figure out what the error message is, that it's reassuring to them to know that even those of us who they look up to as instructors are still learning as well, and that there is no sort of end point to when you know everything and you're all set. So I think that letting them know that we're all learning together helps them be more comfortable with trying things that they see as hard too.
I think that's all great advice. I want to thank you both for taking the time to talk with me today and share some information on Project Eddie and Macrosystems Eddie. It's been wonderful to have you both on the podcast.
You've been listening to the Making Waves podcast.
For more info,
please
visit us online
at the Society for Freshwater Science webpage.
Tune in next time
for another fresh idea in freshwater science.